The speed of light in vacuum, commonly denoted c, is a universal physical constant important in many areas of physics. Its value is exactly 299792458 meters per second, 3.00 multiplication 108 meters per second, as the length of the meter is defined from this constant and the international standard for time. According to special relativity, c is the maximum speed at which all matter and information in the universe can travel. It is the speed at which all massless particles and changes of the associated fields, including electromagnetic radiation such as light and gravitational waves, travel in vacuum. Such particles and waves travel at c regardless of the motion of the source or the inertial reference frame of the observer. In the theory of relativity, c interrelates space and time, and also appears in the famous equation of mass-energy equivalency equals mc2. The speed at which light propagates through transparent materials, such as glass or air, is less than c. Similarly, the speed of radio waves in wire cables is slower than c. The ratio between c and the speed v at which light travels in a material is called the refractive index n of the material, n equals c, v. For example, for visible light the refractive index of glass is typically around 1.5, meaning that light in glass travels at c. 1.5 200,000 kilometers per second. The refractive index of air for visible light is about 1.0003, so the speed of light in air is about 299,700 kilometers per second, about 90 kilometers per second slower than c. For many practical purposes, light and other electromagnetic waves will appear to propagate instantaneously, but for long distances and very sensitive measurements, their finite speed has noticeable effects. In communicating with distant space probes, it can take minutes to hours for a message to get from Earth to the spacecraft, or vice versa.